Good morning. I'm Dr. Mahajan. In my previous lecture, I discussed what is probability, what is the application of probability, what is success, what is failure. We also discussed the distribution, what is the distribution, discrete distribution, continuous distribution, and so on. Now, today we are discussing sampling. So, today in my lecture, the outlines are what is sampling, need of sampling, and various sampling methods. Sampling. Sampling is a portion of population of interest or and sampling is the process of drawing a sample from the population and studying that sample to gain insight about the entire population. It means in the diagram it shows that there is a population and one is a sample and so many samples is considered as a population. It means we are not study full population, we are taking a sample and according to sample we refer to population and take a decision. Now result to sample, why I am choosing a sample not population. So sample, reason to sample, studying entire population is time consuming, costly to study entire population, destructive nature of some tests, result from the sample are sufficient. So that we are considering this sample. So what is the sampler? What are the sampling methods? So I define here diagram sampling method divided in two parts, random and non-probabilistics. Random also divided in four parts, simple random, systematic random, stratified random, cluster random, and non-probabilistic divided into parts, judgment, and second convenience. So these are the sample structure. According to sample methods, we are distributed into parts, and this two part is subdivided in random 4 and non-probabilistic in two parts. Now, probabilities. All the items in the population have a chance of being chosen in the sample. Now, non-probabilistic items are selected from the population using the person knowledge and opinion or someone expertise. Right? Now, what is simple random sampling? Each item in the population to have an equal chance of being included in the sample and allows each possible sample to have an equal probability of being picked. So that simple random sampling divided in two parts. The first is simple random sampling without replacement and second simple random sampling with replacement. Here I am giving one example. Suppose I am take one example, a bag is there and there are 5 balls in this bag and 3 balls are whites and 2 balls are red, and suppose I draw one ball. So which ball is coming here? So red ball is coming, so I am not replace this ball and again I draw the second ball. So this is the without replacement, and suppose I put this ball in the bag, so this is the replacement. Now the second part, types of simple random sampling. Simple random sampling without replacement is what? When an object in the population can be selected only once. We are sampling without replacement. Here I am taking the example population. So for chances of there are 6 sample. Now the chances of 1 is 1 by 6, sample of 2 is 1 by 6, 3 is 1 by 6, 4 is 1 by 6, 5 is 1 by 6, 6 is 1 by 6. So sample random sampling is size is equal to 3. Right? Now 1 by 6, 1 by 6, 1 by 6, it means 1 by 5, 1 by 5, 1 by 5 is possible because I am considering here 2, the 2 is not there, only 5 are possible. It means m upon n, I substitute the formula m upon n is now 5 because 2 is not involved, and 1, 3, 4, 5, 1 by 5, 1 by 5, 1 by 5, right, for 2. Now, systematic random sampling. It is variation of simple random sampling. In this technique, sample members are selected based on random starting point and fixed predefined interval. Third, each element has an equal chance of being selected, but each sample does not have an equal chance of being selected. Now, here I am defining population. There are 12 population, 1, 2, 3, 4, 5, 6, 7. Now, sample size equals to 4. We consider the sample size 4 and we start from 2. So, I consider the 3 interval. First is start 2, second is 5, third is 8 and fourth is 11. So, sample size are 4 and I take here 3 intervals. 2 jump to 5, 5 jump to 8, 8 jump to 11. Now, 2, 5, 8, 11 is my samples, right? Now, advantage and disadvantage. What is the advantage and disadvantage for this method? The simple random sampling and systematic sampling are simpler than other more sophisticated probability sampling method, right? Now, may require less time and results in lower cost. Third, systematic sampling is prone to selection bias. If there is a pattern in the frame, there could be serve selection biases. And fourth, works well with a large sample size. Okay. Now, what is stratified random sampling? In this method, strata is plural form of spectrum. Spectrum is defined as level or class to which people are assigned according to their education or income. In this method, stratified random sampling, population is divided into classes or subgroups and a random sample is selected from each class. And fourth, sample size is proportional to class size when compared to population. This assures fair representation of all classes. Now, I am taking here one example. For example, consider a company which has 1000 employees and has 5 departments. Number of employees per department are as follows. Departments are 5 here, A, B, C, D, E, and their number of employees in A 20, B 280, C 400, D 260 and E is 40. Now, in this method, the company wants to select a team of 50 employees for a communication skill training. If simple random sampling is used, employees from department A and department 5 have less chance of getting selected. So, to ensure fair representation for all departments, stratified random sampling should be selected, right? So, in this method, how to select it? First, we identify the relative frequency. It means we check here our employees are 1000. It means we divided every department by 1000. So, in the A department, the relative frequency is 20 upon 1000, that is 0.02. And their employees are, there are 50s, we required the values, so 50 into something, 50 into 0.02 equals to 1. And so on, we calculate all these things. So, number of sample here 50, so we can multiply by number of samples. So, the relative frequency sum is 1 because we know that probability belongs to 1. Their sum is 1. Now, so what is the advantage? It is appropriate when the population is already divided into groups of different sizes and this fact is known. Properly designed stratified samples more accurately reflect characteristics of the population than other kinds of samples. The homogeneity of items within each spectrum provides greater precision in the estimates of underlying population parameters. Now, we discuss the cluster sampling. The clusters are often naturally occurring designations such as election district, city blocks, households, or sales territories. Take a random sample of one or more clusters and study all or few items in each selected cluster. So I am defining here population with 6 cluster and sample with 2 cluster. I choose 3, 4 and 9, 10. It means 2 cluster I am choosing here, but cluster are total I defined 1, 2, 3, 4, 5, 6. Every block I consider 2 and we chosen for sample with 2 because populations are totally 16 and I select only 2 cluster. It means we say that there are 8 cluster but I choose only 2 cluster. So what is the advantage of this? Cluster sampling is often more cost effective than simple random sampling, particularly if the population is spread over a wide geographic region. However, cluster sampling often requires a large sample size to produce results as precise as those from simple random sampling or stratified sampling. So, here we discuss the random sampling. Now, we discuss here non-random sampling. So non-random sampling are divided into two parts. First is judgment and second is convenience. In non-random sampling, the some parameters are there. Does not involve random selection. Second, units in the population do not have known chance of being selected in the sample. The third point, it is less representative and valid, but it more convenient. Number fourth, usually part of pilot or trial project. So we can using in pilot project. Now the non-random samplings divided into two parts. So what is the convenience and what is the judgment sampling? In convenience sampling, a convenience sample is either a collection of subjects that are accessible or a self-selection of individual willing to participate. For example, I am taking here one example. A group of students in a school are asked to do a study about favorite subject of students. They pick up students from their school and few students from their neighborhood. So this is the convenience method. And in a judgment method, get the options of pre-selected expert in the subject matter. Although the expert may be well informed, you cannot generalize their results to the population. The example is TV reporter stopping people on the street to ask them their opinion about recent event. So TV reporter needs to use judgment when deciding who to stop for asking question. So these are the sampling and judgment differences. Now, what is the advantage and disadvantage are these methods? So inconvenience, speedy and low cost, and lack of accuracy due to selection bias. The result cannot be used for statistical inference. So now I summarize in my this lecture what we'll learn. So first, what is random sampling? Now random sampling divided in three parts: simple random sampling with and without replacement. Second, stratified sampling, and third is cluster sampling. Again, we learn what is the non-random sampling methods. The first is convenience sampling and second is judgment sampling. Thank you.